So guys, in this video, we will discuss about that what is the applications of Neutron-Raphson method. So now we are going to discuss about the applications of Neutron-Raphson method, and we will solve some problems on the applications of Neutron-Raphson method. So now here I'm just going to discuss with you that what is the application of Newton-Raphson method. The application of the Newton-Raphson method is this: the Newton-Raphson method has an application to find the mth root of a positive real number, and also we can evaluate the reciprocal of a positive real number. So now I'm going to discuss with you the first one, that is how can we find the mth root of a positive real number. So let's see that how can we find it. So here I'll just show you that how can we find the mth root of a positive real number. So here I'm just telling you that one thing, that if we consider equation, that is f of x is equal to x to the power m minus r is equal to 0. That means from here we can easily write that x is equal to mth root of r. So now this r must be a positive real number. This r must be a positive real number. So it may be prime number, it may be even number, it may be odd number. So now here, let's see that how can we use here the Newton-Raphson method. So what is the Newton-Raphson method? We know that xn plus 1 is equal to xn minus f of xn divided by f dash xn, provided that f dash xn is not equal to 0. So now if this is f of x is equal to x to the power m minus r, so f of x is equal to x to the power m minus r. So from here we can easily write that m dash x is equal to mx m minus m x to the power m minus 1. So from here we can write that f of xn is equal to xn to the power m minus r, and m dash xn is equal to m xn m minus 1. And now if we put these two results here, so now let's check that what we get. That is what we get, that is xn plus 1 is equal to xn minus xn m minus r divided by m xn to the power m minus 1. And if we now simplify, we will get, that is, this is m xn to the power m minus xn to the power m plus r. So from here we can get m minus 1 xn to the power m plus r divided by m xn to the power m minus 1. So this is the working formula for finding the mth root of a positive real number. So now here I am just going to show you by one example that how can we find the mth root of a positive real number. So see here that here we will find the approximate value of root over 12 using Newton-Raphson method. So here we can say that let, for the solution, that let x is equal to root over 12. So from here we can write that x square minus 12 is equal to 0. Or now we can write that f of x is equal to x square minus 12. So now from here how can we find it? That is, first of all we have to find the roots, that the interval where the root lies. That is, so now we can say that from here if we take x is equal to 3, so f of 3 is equal to 9 minus 12 is equal to minus 3 less than 0, and f of 4 is equal to, so we can say the root lies, or the value of root over 12, the value of root over 12 lies between 3 and 4. So now we can specify it by more. If we find the interval or the midpoint of this interval 3 and 4, so the midpoint of the 3 interval, that is 3 plus 4, by 2, that is the midpoint. Suppose we say that is x0, that is 7 by 2, that is 3.5. And now if we check the f of 3.5, I think that will be 3.5 whole square minus 12, that is greater than 0. So now we can say the root more specifically lies between 3 and 3.5. So here we can set our initial approximation. We can set our initial approximation as 3.5. So now the question is that, so now we have to find the solution of this equation. That is 3.5. If we take that is the initial approximation as 3.5. So now how can we solve it? That is the form is xn plus 1 is equal to xn minus f of xn divided by f dash xn. So how can we find? That is, if we put n is equal to 0, that is x1 is equal to x0 minus f of x0 divided by f dash x0. And so from here also, that is f of xn is equal to xn square minus 12. So f dash xn, this will be 2xn. And now if we put here, or now, that is if we put the values, or here I can use the more simplification rule here. That is, if you follow this formula, that is f of xn plus 1 is equal to m minus 1 xn m xn to the power m plus r divided by mxn to the power m minus 1. So from here we can say, so I just show you it here again. That is xn plus 1 minus xn square minus 12 divided by 2xn. Or from here what we get, this is xn square plus 12 by 2xn, and this will be half of xn plus 12 by xn. So this is the for this one. So from here we can write xn plus 1 is equal to half of xn plus 12 by xn. So if we put n is equal to 0, so I get x1 is equal to half of x0 plus 12 by x0, that is half of 3.5 plus 2 by 3.5, and if we calculate we will get 3.46429. Similarly, if we find, if we put n is equal to 1, so we get half of 3.46429 plus 12 by 3.46429, and from here we will get 3.46. If we simplify we will get this one. And now if we put n is equal to 2, we get x3 is equal to half of 3.464102 plus 12 by 3.464102, we will get the value 3.46410. So see here that if we follow it, we can say easily the value of root 12 is equal to 3.464102, and you can check it also by your calculator. So I hope you understand that how can you find the roots of a how can I find the mth root of any given equation. So thank you for watching the video.